Context,
So you were blinded.
I was blind.
It's unlimited, but
Did you take a hard test?
yeah.
Two different visions, so.
Oh, really?
But
So
you
stigmas
can
are
only
bad.
open it once.
And I have a prism effect, so it doesn't work.
Oh, gosh. So you're just all messed up. Your eyes are just
Real messed
It's
up.
kind of like having two phones in a way.
really.
I was sleeping for like 30 minutes.
Wait, how? We were like, I was so bored.
I was tired.
Can I look through your glasses real quick?
Yeah, I can if you want.
Okay. Bring them on over.
Or did you get like a fresh cut like this week?
Oh, Sunday.
You said it? Of course I did.
They're not,
You gotta put them all the way on.
It's just
Brad.
my eyes are kind of off balance.
They're
maybe.
not that awful. Put them on.
Okay. Let's just pass them around.
All right.
Yeah.
And my glasses.
Okay, yeah, give them back.
All right. So, okay. So, first of all, okay. All right. We need to talk about the rules, and I want to do one problem today on just basic rational functions, how to graph. Here's what I want to make sure of. Do we know the rules? Do you know like each step? Because with every day, if you haven't noticed, like so we did Wednesday and Thursday, we've been doing different rules for the horizontals. Like Thursday's rule, you have to divide the front two items, and that's where the horizontal is. On Thursday, yesterday, we did the slant. Well, now today we're gonna do a horizontal, but it's always at 0 and no other option. Okay, so here's the idea. I'm just gonna make up a problem here. So let's go with x squared plus 4x minus 5.
So in theory, that should be easier then. If it's all
It should be.
0.
It's always at 0 on this one. And then my denominator here. Let's go with 3x to the third plus 4x let's go x squared plus 1x.
Wait, one question.
Yeah.
So if it was 3x on top and 2x on the bottom, or like 2 squared or something like that, that's when we do the normal division?
Yeah, so
Okay.
the idea is if this was squared,
Yeah.
like if you didn't hear, if this is squared, then the idea is that you would divide whatever the leading numbers are. And that's where the horizontal
And that's
asymptote would
if the
be.
top is greater than the bottom?
If the top is greater than the bottom by 1,
Yeah.
that's when you do the long division. Yeah. Okay.
No.
All right, and again, I'm going to pull up all the rules so that you can see all of these. So, all right, now, do we agree the denominator is larger than the numerator?
Yeah.
The denominator is bigger than the numerator, right?
Yeah.
So that means you're going to have a horizontal asymptote automatically at 0.
Why?
Because the bottom is technically bigger. Ryan just checked in. You want to click in that? So.
Hi, Ryan.
All right, so we automatically have a horizontal. Now again, I'm going to go through all the rules here in a minute, so you have them in written form. I added them to the website last night, so if you want to go back and look at them, they're there. I'm going to pull up that website so you can see them here in a minute. Now, let's walk through how we do this problem. So we're going to walk through all the steps that I normally do. So the rules that I have, number 1, we check X-Intercepts first. So that requires you to factor. You have to factor the numerator. And these are on the website, by the way. I have them all kind of written out. Number 2, the second rule we're going to do. We're going to do the vertical asymptotes. We're going to do the vertical asymptote. And again, this is the second rule that I always do. The rule for finding vertical is you have to factor the denominator. Third rule, Y-Intercepts.
You're going real cool.
Yeah.
Yeah, what in the world are we gonna all go over today?
Just want to get through this one problem, let those Spanish kids get going.
Um,
All right, Y-Intercepts. Now, how you do this is the part that I made a mistake on yesterday. You have to substitute 0 for all x's. And that's top and bottom. And then you have to simplify, and that'll be your Y-intercept.
Oh God.
And the last rule, number 4, that's your horizontal. And that's the one that has multiple steps. That's the one that was, I think, catching people. They don't know what to do and when. Because there's like 4 different outcomes that could happen on a horizontal. And we've only done 3. This will be the third one today. The horizontal asymptote.
Are these rules or
I don't
steps?
know. Actually.
These are steps plus rules
So
mixed
they're
in.
the same thing.
Yeah. The rules and the steps are the same.
Well, I wasn't here when you went over the everything.
Okay, all right, now,
I just wasn't paying
okay,
attention.
for the horizontal, there's four basic outcomes. Okay? There is 4 outcomes. Those are the ones I want to make sure that you get written today. I'm going to pull up my website because I have them typed out there. I'm not going to write them up here. It'll look terrible if I wrote them all up. Okay. Are we ready to go here?
Yeah.
We're ready to start.
Find X.
Okay,
factor.
so factor the top. What do we get?
I'm not very good. You're gonna have to help me.
It's a trinomial.
Trinomial. I thought you were good at trinomials.
Plus minus.
What?
Plus minus.
X's.
X's.
That's as far as I can.
Now we have to bring up the 5 in the back.
Plus 5.
1 and 5, and it matters where you put them. 5 and 1, because that'll make the 4 in the middle. Positive 5, negative 4.
So it's trinomial, so it breaks down into 2.
Positive 5, negative 1. That makes the 4 in the middle.
What?
And it
Oh.
multiplies to give you the 5.
Oh, got it.
Okay, now the bottom.
Didn't we do this one yesterday?
It was something similar to it. I think it was about the same numbers.
I think it was before.
I think it was
See,
6
like
and
on this
5.
one, 5 times 1
It was
times
that
negative 1 is
horizontal.
5.
Yeah.
Then 5 minus 1 is 4.
Yes.
But on the test, it didn't equal the 1 in the middle.
Yeah, because they had a number out front. So the number in the front and the back both have to work in tandem together, because the number in the front you'll have to FOIL to see if it makes the middle number. Like the bottom one I'm about to do.
Oh, yeah.
All right.
And where did you get the plus minus?
Right.
The symbol in the back is, it tells you that. If this is a minus sign in the back, it's automatically plus minus.
Okay.
If it's a plus sign in the back, they're going to be the same operation, and you have to figure out what they are.
You gotta figure it out.
So that's what I'm going to do on the next
But
one.
it shouldn't be, if we know that it has to multiply to 5 and add to 4, we should be able to figure that out.
Exactly. You should be able to.
So we don't really need to know.
No. Okay, next. So the bottom. They have common factors on the bottom. I want to pull out an X. So on the bottom, factoring that up, and again, I know I'm factoring everything right now because I'm going to do the 2 first steps really quickly. So I'm pulling out an X on the top. So I'm left with 3x squared, 4x plus 1.
No, that's
You just simplify that down.
also 3 terms, but that's
Yeah,
not.
that's a trinomial, so we'll have to factor that further.
Oh,
So, yes. What was the question? Sorry, I missed it. Oh, I thought I heard a question. All right, let's do the bottom now. Let's factor that out. So we've already pulled up the X. That was a common
X
factor.
plus 1, X minus X plus 1.
Yes. So you're absolutely right. It's going to
Slow
be
down, Rain Man.
That's the one.
all right. So pulling up the X out of the bottom, we have the
3X,
2
not
parentheses.
5.
What you did the top.
Oh,
It's going to be plus and plus because they're the same. They're both the same operation. They are both plus signs. That's how I know it. Now, breaking up the 3 in the front, it's 3 and 1. So 3x and 1x. That breaks up the front number. Breaking up the back number, the 1 in the back, well, that's 1 and 1. And that should work out if you FOIL it to make the 4 in the middle, if you actually FOIL.
so if the number in the back weren't 1, how would you break it up?
So if the number in the back was, let's say, like a 12,
Okay.
well, then you're going to have to figure out how to break up a 12 in the back so that when you start mixing and matching them together and FOILing it out, it will make the middle number, no matter what.
So you have to FOIL everything you try.
You have to practice it, like FOIL it back together to see, did it make the middle number? If it didn't, make a new combination. Maybe you have to switch the numbers. Maybe the signs were wrong. Maybe it was just a different combination. Instead of like 12 and 1, maybe it was 3 and 4, or 2 and 6. You have to try different combinations.
Yikes.
So it's always significantly harder when the front number is a digit, like mine, like a 3. It's harder because you have to FOIL it. There's no like rule I can magically tell you. And Ryan, if you have questions, don't be afraid. Just unmute yourself and fire away. Sorry, it automatically mutes people. All right.
Hey, Ryan.
So so we've got to this point where we factored. So now that we've factored everything, now I can do the first 2 rules because the first 2 rules required that I factor. That's why I always just do it right away. So X-Intercepts. Look at the tops. What makes the tops
I just want to see if that's
zeros?
Negative 5 and 1.
Negative 5 and 1. All right. So these are my X-Intercepts. It's negative 5 or positive 1. It's what makes the parentheses equal 0. So what I do is I just set each parenthesis equal to 0 and solve it individually. So it's negative 5 and 1, or just the opposite of numbers. That's the easiest way to think of it. So negative 5
He's right.
and positive 1. Those are my X-intercepts. Now, I know you're thinking, Ward, you just told me the horizontal goes through the origin. How come we can have dots there? Remember, the horizontal asymptote is a guideline. It's not like a vertical. You can cross through a horizontal. It's just telling you where the tails are going to go in the very end, on the outside.
Wait, so what are those?
So those are my X-intercepts. These are X-intercepts.
Vertical asymptotes are
That's what
crazy.
Yep.
I think it's small.
Okay, the bottom
That's what I
now.
had.
They're about all
Yeah.
Okay, on the denominator. So now we're going to do the second rule. Factor the denominator, we did that. Now we have to read off what all the factors were, the roots were for the bottom.
0,
So we have 0,
-3rd,
negative 1/3, and
-1.
negative 1. Those are all my vertical asymptotes. It's what makes each of those things equal 0. Now, if there's a digit there, like a number out front instead of an X, that doesn't count. It's got to be a variable to count. So if there's something with a variable, you set it equal to 0. So you set the whole parenthesis equal to 0 and solve. That's how we got those 3 numbers. So the vertical asymptote will be at 0. There'll be another one at negative 1.
Wait, if you set
Wait,
the x equal to
what?
0 and it's 3x, that's just 0
Oh,
plus
No,
1.
no. You set the parenthesis equal to 0. So you set this whole thing equal to 0.
Oh, 3x plus 1 equals 0.
Yeah, you set the whole thing, whatever it is, equal to 0. So then you set this whole thing equal to 0, and you go from there. Yeah.
Okay, that makes sense.
And what do we got? Negative 1/3? Oh my gosh, this is terrible. Man, they're so close together.
Or
They're just something.
Fine.
bad.
Yikes.
Why?
That's ugly. Morgan, maybe when you're drawing that, maybe spread them out a little more and just tell the spacing. So,
Yeah.
they're really
Bad or
close. Sorry.
bad.
All right.
Really
Looks like a
bad.
highway.
Yeah, it's really bad. All right, so on this picture, we have 4 drawings.
What's the 0 for?
That was the X out front. That one was 0.
Do you have all 3 of them?
Yeah, you have all 3.
Oh.
I have 3 intercepts on this thing. Or 3 vertical asymptotes, sorry.
So what, instead of saying vertical asymptote
looks
factor the denominator, it's really just solve.
Yeah, I mean, you factored it apart.
Once you factored it,
then you gotta solve it, set it equal to 0 and solve, yeah. That's a good way to put it. Okay, so we have 3 vertical asymptotes. That means there's a graph between each one. That's super ugly. Because there's too many things. What?
4?
What was that?
You're gonna have 4?
Yeah, so we're gonna have 4 pictures. We have one on the left side, somewhere over here.
Goes up.
We have something in the middle here, we have something in the middle here, and then something over here.
Gorgeous.
Yeah, it's just kind of ugly. Now, what we have to do is figure out, there's no Y-intercept to this problem. Now, here's why. If I plug zeros into all of these things,
-5.
you would get a
Oh,
0 on the
0.
bottom that causes a problem. And we already threw out 0. We can't have 0. The origin doesn't work. Because that was my vertical asymptote. So this thing doesn't have a Y-intercept. Because I can't plug zeros into all the X's.
What do you
Trend.
just get left by -5?
No, because you have to plug zeros on the bottom as well. And so you'd have a 0 on the denominator, and that doesn't count. That's an improper math. So you have to plug it into the top and bottom to figure out what Y-intercept. That was the problem I made yesterday.
I'll do it tomorrow or something.
All right. Question.
It's like that wooden one.
No.
Okay, so now,
Oh,
horizontal. There's 4 outcomes. This is the last part we have to talk about. There's 4 possible outcomes for
One in
horizontal.
between the two.
There could be no horizontal asymptote at all. That's where the top is bigger than the bottom by more than 1. There could be a horizontal at 0, which is what you see here. The reason why there's a horizontal asymptote through 0, the bottom was bigger than the top in terms of variables.
Every time it's at 0.
Yeah, so it's always at 0 when the denominators are bigger powers, right? On the next one, the next outcome that could happen is where the top is bigger than the bottom by 1. The top is bigger than the bottom by 1. That's when you have to do the slant. You have to divide, long
Can you
divide.
say that for the first one?
What? No, when the top is bigger than the bottom by more than 1 power. So it's like x to the 4th
What
over
is 0? What
x.
is like none?
That's when there's no asymptote.
Yeah.
When the top is bigger than the bottom by more than 1. That's when there's no asymptote at all.
So what did you just say?
When the top is bigger than the bottom by 1 power, 1 degree. You have to do the slant. You have to long divide. I'm going to put it up on the board so you're not lost here in a second. I have all 4 typed out.
Yeah, that's.
I can't say them out loud. There's too many. I just have to type it out. Because otherwise you just get confused by hearing the same words over and over and over.
When did you do Y-Intercepts?
Y-Intercepts, that's when I factor the bottom.
If you have to draw the arrow.
Oh, Y-Intercepts, that's when you have to plug in zeros out. Sorry.
There is no.
Have you done that yet?
There is no Y-Intercept.
Wow.
Because I plugged in 0 to all my X's and I got a 0 on the bottom. You can't divide by 0. We already threw out 0. You can't use it.
How do you know that?
Can't use the Y-intercept. It literally threw out 0.
Oh, because the X in front is 0?
Yeah. That represents 0, like that vertical
0
aspect.
for the whole thing.
The whole thing, like vertical
Oh,
is
because
0.
you're taking everything in the parentheses times 0.
No, equal to 0. That's what we're doing. The whole thing.
Sure.
Okay, now what we have to do is draw. Now, this is the part where sometimes you're guessing, sometimes you're making an educated guess at it. You know, it could be something like this, where, you know, they kind of go like that. It could be the other direction. Now, the reason why I kind of think this is what's happening is because I have to hit the x-axis, and the tails have to hug up against the asymptote. The asymptote was at 0 on the horizontal.
So it has to stay
So
close to that.
it's either really close to
It has
that
to
as you
go
go to the
through it,
left,
correct?
or it could be going down like that. But the tail on the left has to be hugging up against it. So it's gonna be one or the other. You just have to commit to it.
Oh, you don't want us to draw both?
No, we're gonna keep going. We're gonna keep going. You don't have to draw both. You just have to commit to one of them.
But it has to go through it because.
It has the
There's an
axis.
X
Yeah.
intercept.
And same with this other side. This other side has to do the same thing. And usually they're kind of mirror images.
Through it and then hugs it.
Yeah.
Yeah, how do you know which way to go?
I'm guessing. That's the problem. Like, it is a mere guess. If you really want to know, like, exactly where it's going, plug in a few numbers. Oh, that's actually
But it's
wrong.
okay. We don't have to.
Wait, can we get it wrong?
Yeah, I mean, yeah. So if you have them like accidentally flipped, you're fine. You're making an educated guess where you think it's going.
So if our arrows are wrong, we won't get it wrong.
No, as long as you know that you have to hug up against that.
Well, as long as, do you have to hook up against it or do you have to?
As you go to the left, it has to hug up against it. It can't be like just going down this
Why
way.
doesn't the one on the right start up and then go down?
It could, but usually what happens on these types of problems, they're usually like mirror images.
So I could redo it the other way and still be right.
Yeah. Just right now, this is the actual drawing of it. We've already seen it, but I'm making a guess at it.
So say I did the right side like the left side.
So, so you did like this one over here and that one over there?
Yeah.
Yeah, you're fine. I'm not gonna count it wrong. You're making an educated guess where you think it's going. Now, the middle is probably doing things like this. It's probably doing graphs where they're not crossing. They're not crossing the x-axis. So they're doing something like where it's being like a little U shape in there and a little U shape in here. Now, I'm just guessing where they're going.
This is obvious. I love it.
Yeah, it's really small. I can spread it out and just make the spacing better. But there is a U shape in here, and there's a U shape in here, and I'm betting on they're probably opposites.
What's the
Right,
blue line
The
for?
blue line is the horizontal asymptote.
How'd you find that?
That is found, that's one of my last rules. When the bottom is bigger in power than the top, it's automatically at 0. All right, so now, so everyone's got kind of a drawing of it. Now, okay, the good questions I've been hearing, Ward, how do you know which direction it goes? Here's how I guess at it. Number one, I make an educated guess by just, years of just kind of knowing they go opposite directions. Or, just plug a few numbers and see where it's going. Like, plug in -4 and see where it's going to be out in the graph. If I plug -4 in here, it might tell me a positive number, so I can go put a dot there. Or plug in like a number like -10 and for x and see what happens. It's probably a negative number.
Top and bottom?
So, top and bottom. You have to plug the number into everything. Okay?
And then we spit out one solid, easy number.
Yeah.
Okay.
Now, let's talk about the 4 rules, how you get your horizontal, because I already had a question asked. What are the 4 rules? I keep saying them out loud, and it keeps confusing you more and more and more. Let me give you the 4 rules for horizontals. I'm going to pull them up on the board just so you can see this. Good job, Mo.
Look at it.
What was that? Yeah, the bat.
Hi, Ryan.
No, look what it says.
Catch this one.
It says shoddy a little baddie.
All right. All right, here we go.
Too short, Paul.
Johnny's got a fatty.
All
I
right.
love the Joe Biden meme.
Mr. Ward.
He's got a fatty.
All right.
Kill it.
Hey, let's stop throwing stuff around my room because if I find it on the floor, you guys are going to be licking it up.
It's paper.
Good, you can lick it up still.
We're in Corona times. We can't lick it up.
That's
Jimmy, take it.
It's a paper.
I did.
I would lick it over for fun.
All right.
Very down and then watch it fly back up. Anyway, yeah, he said that.
Do not cover it.
All right, hey. Okay, let's go through the 4 rules here. Okay, all right.
Is that it then? We're just going over these 4 rules?
Yeah, 4 rules, and this is it.
Alright, turn my calculator off.
Is that all real math stuff for the
Yes. That is all real math stuff.
I do that.
So that's gotta be like
Target, let me
calculus.
see Morgan.
Yeah, you've done half the stuff already. All right.
Morgan, let me see your art.
Okay, calculus from the drop down in daily lessons. I'm gonna go to yesterday's video.
Not very good one.
All right. So, here's the rules that we talked about. Okay, we talked about X-intercepts, vertical, Y-intercepts, horizontal, and if there's slants. Now, for X-intercepts, you have to factor the numerator, and then you solve, right? You find the roots. Vertical, you factor the denominator. Y-intercepts, you substitute X is 0 into everything. Horizontal, here are your 4 rules.
Oh my god.
Now, I'm going to say them and then try to explain it, and this is the last thing I want to cover today. If the highest degree in both the numerator and denominator are equal, so the top variable, the bottom variable have the same degree,
Fine.
you divide the leading digit out front, and that's where the horizontal asymptote goes. So, for instance, if it was x to the 4th over 3x to the 4th,
Do 1/3.
yeah, your horizontal will be at 1/3 because you take the leading numbers out front and you divide them. That's where the horizontal asymptote goes.
That's where it
That's
starts.
something more simple.
That's where it would go. It'd go right through that number on the y-axis. And that's where the tails would,
Oh, da da da.
yep. If the highest degree, so now it's rule number 2. If the highest degree is in the numerator, so the highest degree term is in the numerator, but it's higher than the denominator by 1,
That's the long.
that's where you have to do long division. So, let's say it's x to the 3rd over x squared, and there's a bunch of polynomials here. You have to long divide these, and the item that's left by long dividing, when you do the whole long division thing,
You
right?
have to do 2 though, right?
You only have to get what's on the top. You don't have to finish it. You just have to get 2 items, and it'll be the slant. It'll be the equation for the linear function as a slant slant asymptote.
I don't know.
Because it says it will actually be slanted, and it'll be that linear equation. Rule number 3. Rule number 3 for the horizontal. If the highest degree term is in the numerator, so if the highest degree term in the numerator is somehow lower than the denominator, it'll be through 0.
Got it.
That's what we just did today. The highest degree was on the bottom. It was x to the, what was it, x to the 3rd on the bottom?
Yeah.
Today, and we did x squared on
2
the
over
top.
3.
The highest degree is on the denominator. It will always go through 0 for the horizontal. And you saw that today. The horizontal went right through 0. And if the highest degree is on the top, and it's bigger than the bottom by more than 1, then you have no asymptote at all for the horizontal. Those are your 4 rules.
The bottom could be bigger by like 4, and it'd still be at 0.
Still has 0. These are the 4 rules. It's the hardest thing to explain because it sounds like I'm saying the same thing every time I say it out loud, but there's subtle differences. And that's why I've been typing those out so you can see them super specific. Monday, we're going to practice this more. It's not going away. This is one of the last 2 sections we have to cover before our next major test. Okay? I'm thinking our next test is possibly the end of next week or the middle of the week after. So it'd be possibly it could be like Friday next week, or it could be the Tuesday the week after, so we get some more review days. Because we only have 2 sections left. This one we have to finish to make sure you know how to do it,
Tell semester.
and then the next section, which is on limits.
And then that's,
Or you just look at graphs and you see where it's going roughly.
and then semester.
And then on a midterm number 2, or quarter number 2. Questions? Okay,
What do we do?
Spanish, good luck to you. I'm sorry that took a lot of your time. Sorry it took a long
Do
time
you
to do
like
some of
my
this stuff.
spooky drawings? You like my spooky drawings?
Those are good. All right, take
It's like-
screenshots, all the good stuff. Ryan, thanks for tuning in. Sorry, we'll do some more on Monday.
Yeah.
Aren't you gonna go?
I don't want to.
All right, see you later.
You're just gonna take
I'm
one.
gonna stop sharing Morgan's screen.
Oh, no, never.
What? Why? Is he still on there?
Nope, he just left.
Where you going?
We surprised.